Welcome, students. I am Aurora, the artificial intelligence system on Spacegate Station. In this episode, you will receive a brief introduction to the science of flight. We will review the forces that airplanes have to overcome to fly, as well as the type of control surfaces necessary to keep them in the air. Please stand by for transfer to Spacegate Station.
Welcome, students, to Spacegate Station. My name is Specialist Barber, and I'm the communications officer here on the station. Today, we're going to be helping out our friends over at Starbase by reviewing some of the concepts of flight with you. Isn't that correct, Aurora?
You are correct, Specialist Barber. Although the primary focus of Spacegate Station is scientific research, we are also tasked with providing educational content to help students learn more about science, technology, engineering, and math, just like Starbase program.
Exactly. As a matter of fact, our Chief Science Officer, Dr. Carafano, is presently working with Professor Wright in the lab on a research project that involves something called aerodynamics.
Processing. Aerodynamics is the study of the properties of moving air and the interaction between the air and objects moving through it. Understanding aerodynamics is important as it provides scientific principles that explain how objects can fly in our atmosphere, whether it is a kite, an airplane, or a rocket.
Right as always, Aurora. Oh, I guess it is time to transfer the students over to the Space Lab. Transferring now.
They are still here, Specialist Barber.
Oh, sorry. Must be these switches. Transferring now.
Specialist Barber, the students are still here. Perhaps you would like me to assist you with the transfer.
I am perfectly capable of transferring communications from Earth to the science lab. I will have you know I'm a very experienced communications officer.
Transferring now. Dr. Carafano, the students from Earth are here as scheduled.
Oh, thank you, Aurora. Welcome, students, to Spacegate Station. I'm Dr. Carafano, the Chief Science Officer here at Spacegate. And with me is one of our top research scientists, Professor Wright.
Welcome, students.
Right now, we're in the lab working on a special project for NASA. And it just so happens this project has a lot to do with what you're here on the station to see.
Professor Wright, what type of experiment are you and Dr. Carafano working on?
You know, Aurora, we are developing various experiments to help determine the best way for winged vehicles to operate on the surface of our planets in our solar system.
But before we begin conducting experiments, we have to have a thorough understanding of all the forces that are related to flight.
Processing. 4 forces affect how aircraft fly. These forces are known as weight, lift, drag, and thrust. These forces make an object move up or down and faster or slower. The amount of each force compared to its opposing force determines how an object moves through the air.
Very good, Aurora. You know, Dr. Carafano, I bet we can have Aurora help explain forces to the students so they get a better understanding of the science behind it all.
That's a great idea. Aurora, could you go ahead and review with the students the concepts regarding the forces of flight? Let's start with the first one you mentioned, which is the force called weight.
Of course, Dr. Carafano, weight is the force generated by the gravitational attraction of the Earth on an object. For an airplane, weight is the downward force that it must overcome to fly. The bigger the aircraft, the more force it has to overcome to resist the pull of gravity.
That was a good explanation, Aurora. Perhaps we can move to the next force, which is lift.
Lift is the push that lets something move up. It is the force that is the opposite of weight. Everything that flies must have lift. For an aircraft to move upward and fly, it must have more lift than weight. A hot air balloon has lift because the air inside is lighter than the air around it. Hot air rises and takes the balloon with it. Lift for an airplane comes from its wings. Airplane wings are curved on top and flatter on the bottom. That shape makes airflow over the top faster than under the bottom. As a result, less air pressure is on top of the wing. This low pressure makes the wing and the airplane it is attached to move up.
That was a great explanation of lift, Aurora. Perhaps you could tell us about the next one, which is the force called drag.
Drag is the force of air that pulls back on something trying to move. Drag provides resistance, making it hard to move in the air. The faster you go, the more drag you have to overcome. The shape of an object also affects the amount of drag that can be encountered. Round surfaces usually have less drag than flat ones. Narrow surfaces usually have less drag than wide ones. The more air that hits a surface, the more drag the air produces.
That's right, Aurora. So to fly, we have to have a way of dealing with drag.
Exactly. And that brings us to our last force, which is thrust. Aurora, could you explain to the students what we mean by the force thrust?
Of course, Dr. Carafano. Thrust is the force that is the opposite of drag. It is the push that moves something forward. For an aircraft to keep moving forward, it must have more thrust than drag. For some airplanes, the thrust could be produced by its propeller. A propeller is like a spinning wing. It produces lift, but in a forward direction. For some airplanes, they might get their thrust from a jet engine. A jet engine uses a turbine to force air under pressure out the back of the plane, causing it to move forward.
Thank you, Aurora. That was very helpful. You know, Dr. Carafano, understanding the forces involved in flying is very important. However, I think there's other things to consider.
Oh, you're talking about control surfaces.
Exactly. Without control surfaces, you would not be able to take off, land, or even steer the plane in the air.
You know what? I bet Aurora could help us with those too. Aurora, could you explain to the students what we mean by the concept of control surfaces?
I would be happy to. There are 3 primary control surfaces on an aircraft. They are the elevator control, the aileron, and the rudder. These 3 parts of the aircraft allow it to go up, down, and turn.
Correct. They all work together to help the plane keep itself in the air and moving in the right direction.
You know, Professor, our students may not be really familiar with how control surfaces work.
That's a good point. Maybe we should get Aurora to explain it to them. Aurora, will you first explain how elevator control operates?
It would be my pleasure, Professor Wright. The elevator controls the movement of the airplane about its lateral axis. When forward pressure is applied to the controls, the elevator moves downward and the plane nose goes down. When back pressure is applied to the control, the elevator moves upward and the plane nose goes up.
Thank you, Aurora. That was a great explanation about elevator controls. Why don't you cover the next one with our students, the ailerons?
The ailerons control the movement of the airplane about its longitudinal axis, making the plane tilt or bank. When the bank control is moved to the right, the left wing's aileron moves downward and the right wing's aileron moves upward. This causes the airplane to tilt or bank to the right. When the bank control is moved to the left wing's aileron moves upward and the right wing's aileron moves downward. This causes the airplane to tilt or bank to the left.
I guess the last to discuss is the rudder controls.
The rudder controls the movement of the airplane about its vertical axis. When pressure is applied to the left rudder pedal, the trailing edge of the rudder moves to the left. The resultant force moves the nose of the plane to the left. When pressure is applied to the right rudder pedal, the trailing edge of the rudder moves to the right. The resultant force moves the nose of the plane to the right.
Most importantly, it's these three forces working together that allows a pilot to control the airplane in the air. Thank you, Aurora. That was some great explanations. You know, Professor, I think our students have a much better understanding of the science of flight. Unfortunately, we've got to get back to our special project for NASA.
I was having such a good time, I almost forgot. Well, students, we truly enjoyed helping you learn these important concepts.
And students, you're always welcome back at Spacegate Station because the scientists here love talking about science.
Aurora, let's transfer it back to Specialist Barber.
Transferring now. Specialist Barber, the students are back.
Oh, sorry. I didn't hear you. I was busy doing very important communications work. Well, students, I hope you learned a lot today from our Spacegate Station crew.
With my assistants, Dr. Carafano and Professor Wright were able to cover a lot of information about the science of flight with the students.
Well, that's good to hear. You know, Aurora, I bet you these students would be fascinated by all the skills that I have to have as a communications officer.
I don't think these students have that kind of time, Specialist Barber.
Oh, well, perhaps next time. But you know, Aurora, you've got plenty of time on your hands. Let's see. Where do I begin? It all started a long, long time ago in a city far, far away. It was a dark time in the cold metropolis of New York, and there was an eerie presence that was making itself known throughout the boroughs.
Specialist Barber, I believe I have already heard you tell this story.
Don't worry, Aurora. It gets even better the third time I tell it.
How do I get myself into these things? This concludes our latest episode of Spacegate Station. Please join us on our continuing adventures as the crew of Spacegate Station provides engaging enrichment or remediation-based instruction to improve your understanding of science, technology, engineering, and mathematics. Terminating communication with Earth.